Hello, and thank you for joining this session with dotCMS. In this edition, we'll provide a deep technical and very hands-on training on dotCMS and Docker. But before I hand over to Brent and Chris, I'd like to spend a minute on why we think containerization is important to you. It is our belief that content and a content management system is a foundational part of any infrastructure for organizations who are building a digital experience platform. And it really puts you in a position to not only manage and build, but certainly also orchestrate digital experiences. Without further ado, I'd like to hand over to Brent and Chris.
All right, so now we're recording, and prerequisites don't really want to talk about that much. Hopefully everybody on the call has had a chance to review these videos, or at least are familiar with the content in them. There's some doc there about how to install Docker CE, and talks about setting up a Docker Hub account. So the purpose of this call really is to equip you to be able to run and test dotCMS inside of Docker. Now I could just send you a couple of commands and say, here, go for it. And that might kind of sort of work, but wanted to explain a little bit more detail behind it. And the secondary purpose is to provide you resources that's going to help you dig into Docker and specifically be able to look into our dotCMS images and dig further if you want to understand what's going on. I know some of you on the call will be frontline support. Once we roll Docker out, have to deal with these kind of questions, troubleshoot it in cloud, troubleshoot it in client environments. So I want to kind of provide you some resources. If you haven't had a chance to dig into Docker yet, you can do that, but also, and hopefully it'll speed your progress up a little bit, and also give you some information that'll be able to help you understand more about what's going on inside our own Docker images. Let me paste that link back in for those who just joined so they can follow along. All right, Docker on Mac. A couple things I just wanted to say there. One, on Macs, Docker actually runs inside of a Linux virtual machine. For the most part, you don't need to know that, but as you get into it a little more detail, you'll run into that, and we'll actually even cover a couple of settings here that we need to make sure that we set for the virtual machine. I do recommend that you use Docker for Mac rather than just installing from Brew or MacPorch or something like that, because Docker for Mac includes DrCompose, which is a separate utility, but Docker for Mac kind of downloads it all together. And Docker for Mac just gives you a UI to set some settings that you can do during the command line, but it's just a little more involved, and I think Docker for Mac is a better way to go. When you have Docker installed and running, I don't know if you can see in my upper right-hand corner here, I've got the whale with the containers on it. It tells me that the Docker is running. Basically, that means that the VM is running. And I want to come here to Preferences. Because we are running inside of a Linux VM, you can set the number of CPUs and the amount of memory that you're going to allocate to it. Reason this is important is I think the default, I can't remember, Chris, is the default 2 gig memory?
Yeah, it's 2 gigs, which is fairly limiting.
Yeah, so once you start running a bunch of Java containers, 2 gig runs out pretty quick. So the first time you do that, you might see your processes start getting killed off like crazy and restarted all the time because you're running out of memory like I did. And then you just need to come in here and bump your memory up to an appropriate setting based on what you're doing.
Yeah. So that being said, it's important to understand that Docker is not a full virtualization isolation technology. Docker is just an extension to the Linux kernel, and a Dockerized container or a Docker process is a process running in the same operating system environment as the host OS. It just has some certain barriers put in place around it. So when you look at your memory allocation, here we're configuring the actual memory used for all of Docker. It's not the same as with virtual machines, where with virtual machines you have to allocate a huge amount of memory, a lot of overhead, a lot of wasted memory. With Docker, it lets you use that same memory more efficiently because these are just process. Each container is a process running within a single VM.
So So the one other setting I just want to make sure we mention in here is the file share, and we'll talk a little bit more about this. But any files you want to make accessible to your Docker containers, similar to when you set up a VM, you have to basically set up a file share location. This is where you would do that. One thing I was going to say, follow up to what Chris said, is if you ever want proof about how the processes are running when you're running inside of Docker, you can do a PS and you'll see the actual processes from your Docker containers right there in your host operating system, as well as what user and everything they're running as. So definitely much more lightweight than VMs, and we'll see that here. Then in the doc here, I did provide some common error messages. Won't elaborate those now, but hopefully those will help you as you get started. If you see those, it sounds stupid, but I get this one here all the time. Docker command not found. It's like, oh, I forgot to start Docker. Things like that. So one thing, Docker -- help is your friend. It kind of will list out all the different command options you have. I'm not going to go through those in detail. Want to just point out the difference between these management commands and the regular commands. So when Docker first started out, it didn't have a full object set. All the commands were kind of Docker this, Docker that. As they started adding more complexity to Docker, they started adding more of these management commands just because it started getting unwieldy. So for example, you can say Docker pull and give it an image name, and that'll pull an image. That's kind of the old interface. The new interface is Docker image, then pull, and then the image name. And it's just a way of kind of segmenting out the UI command or the command line options there. But that's the main difference between these management commands. The management commands basically will have subcommands to them usually as well. All right. So with that,
context commands.
Right. So what I'm going to do now, and I know we're kind of going fast, and again, the intent here is not to be a Docker 101 class, but kind of get you exposed to it, get you kind of the information you need to know right now, as well as information to dig in more on your own. I do want to look at Docker Hub. So if you go to hub.docker.com, if you have an account, you'll see something like this where it lists all your repositories. Hub.docker.com, it's a registry of repositories. And repositories, I know all the developers here, you're familiar with Artifactory. Just think of this as a repository for Docker images. There's many different options here. This is one that Docker provides for free. Basically, you can build images, push them up here, and then download them, have your clients download them, whatever. And so if we go, we look, I was going to go look at OpenJDK here. If you search for OpenJDK, first list here, you'll see the official JDK repository, OpenJDK. And I give them as an example just because they have a lot of tags, and everything that's listed here is a tag. A lot of their builds have multiple tags on it. There's a number of reasons for that. They're tracking everything from the Java version to what operating system it's installed on, whether it's a JDK or JRE. And then the one thing I want to make sure I pointed out is with labels, sometimes you'll see, find an example in here. For example, if I use a label of 8-JDK that we see here, it's going to pull the latest Docker file, Docker image for OpenJDK 8, whatever that version is. So if I pull it today, it's going to be 171. If I pull it 6 months from now, who knows what the version is going to be. It's going to kind of float with whatever the latest Java 8 JDK version is at that time. But you can also get much more specific, and you can point out, I want version 8, update 171, et cetera, and that's going to lock you to a specific version. Works just like your dependencies in Gradle, right? You can specify a specific version. I only want this version. Do not update it unless I tell you to. Or you can say, hey, I kind of want the latest version of this library, and that's going to update as that library updates over time. Same idea, just Docker images instead of jar files.
What is really important is if you don't specify a specific tag version, it will pull the tag that's called just latest, and the tag that's defined as latest might not necessarily be the latest. All of these tags are just text labels that were assigned at the time the image was pushed. So latest might actually be the first image that was pushed without a label, and it could be actually the oldest. So it's good to be definitive about this.
Yeah, I think for production purposes, we see us being very explicit here, right? We don't want just to let Java update whenever it wants to necessarily. We'll probably want to be very specific so that we want to control when we upgrade to a different version of Java or whatever. So then I was going to look at our repositories. If you've set up a hub.docker.com account, you should have access in this pull down here to dotCMS. Here's the different repositories we have. Right now they're all private. That's just because you know how it is when people find some images up there. It won't be long. They'll discover them. They'll download them. They'll be calling support for helping them. So right now we're keeping them private. That's why if you want to access these, you need to make sure your account's set up so that you can access the dotCMS repositories. And if you need access to that, message me or email me after this, and we can get you set up. Right now, all the images that we're really using are here in this dotCMS/dotCMS repository. The syntax here really is, the first one's the organization name, and then the second one is the repository name. And then as you'll see, we have multiple tags right now within the repository. We haven't figured out our exact final naming scheme yet. If each one of these might have their own repository, we don't know yet. We got to work through some of that. So let's see. So right now, if I wanted to, if you have access to the repository, you could say Docker pull and list out the image that you wanted to pull, and it'll pull it down. I think our image right now is about 358 meg. So depending on your connection, may take a little while.
Yeah, and one aspect of that is that each image is made of one or more layers, and each layer is cached locally. So it will only pull the layers that have changed. With dotCMS, typically the artifact within the image that changes is the dotCMS installation itself, which is the largest part of it. So the layer caching doesn't necessarily optimize a lot there. But sometimes you might pull an image and it might take a lot less time than you expected, and that's not necessarily a bad thing. Doesn't mean it broke.
Right. So what I like to do now, so these is just kind of repository. These are images that are up there, just like you pull down jar file dependencies. These are Docker images that you can pull and run, or you can use as kind of a base for your own image. I kind of wanted to walk through a really simple example here of a Docker file. I just basically wrote a simple little Java program that prints out hello world, basically. The Docker file is as simple as this. The first line is saying, I want to base this off. My base image is going to be the OpenJDK 8 JDK Alpine. Alpine is an operating system, a really small optimized operating system. But basically that image is going to start out at 4 meg and then add Java and everything to it. And then it's going to copy my Java file basically into the image. It's going to set the working directory. Basically, that's just the directory that when the image starts up, that's going to be the default directory. It's also going to be the default directory for the rest of the Docker file. And it says, hey, compile this Java file. So it's going to store that hello docker.class file in the image itself inside of this working directory. And then the CMD is basically saying when the container starts up, the command I want you to run is Java, and I want you to pass it a parameter of hello Docker. And so what we want to do is I want to issue a simple build command here. I'm going to say build, and I'm passing a tag called JB Griffin Hello Java app. So JB Griffin is the organization name, me, and the Hello Java app is the name of my application as I put it on Docker Hub. And the period just says, look here locally for the default Docker file. So if I run that, it runs really fast. But what you'll see, to Chris's point, is a lot of these lines say using cache, using cache. It's because it's detected, look, I already did this before. The file hasn't changed. I'm not going to do it again. I'm just going to pull it from the cache. So if we look at, this is just a list of all the images I have here locally on my system. It caches just like Gradle kind of does. Not just like it, but similar to what Gradle does. Caches them locally on the system. So you'll see here this first line. I did this before 29 hours ago, and it's 102 meg in size. And basically, it's saying, look, you told me to build it. I've already got it. Here's the hash for it. And I'm good to go because it's already updated. So that builds a Docker image. And to Chris's point, each one of these lines in the Docker file creates a new layer in the image. So as you looked at those videos, they talked about how images have multiple layers in them. Every line in your Docker file creates a layer in that image, which is why sometimes when you see some bash scripting and stuff, you'll see them making really long lines with double ampersands where they're basically chaining all the commands together, because what that does is it takes all those commands and runs them and puts them all into the same layer in your image file. All right, so we did that. I guess, let's see where I want to go from here. Did that. Oh, I guess the one thing I was going to say that I forgot, just to kind of provide you a background, this is a legacy Docker file. This is something I don't even remember, Vianney, if it was you or me that wrote this, but this is a simple Docker file that we created before we went to our boxbook training and all that stuff. It's simplistic. It would work for a basic kind of demo kind of functionality, not really for scaling and all that kind of stuff. But basically, if you look at this image, right, it's saying, okay, we're basing it off OpenJDK8. It's putting some labels in there, which really is just metadata that can be available as you inspect the images. Setting some environment variables here. You know, at the end of the day, what it's really doing is it's grabbing a tar file and it's untarring that file into the image and telling you, okay, when you start up this container, run this entry point sh, which, you know, behind the scenes is going to start up Tomcat and all that. But this is, I included this because it's, as you're getting started, it's going to be a much simpler example for you to understand what's going on there. Before you move into some of the more sophisticated stuff that has been created, because we've added a lot of, Chris has added a lot of stuff there for auto discovery and different things that really need for production environments to be able to scale up and have externalized Elasticsearch and externalized cache and a lot of those enterprise type features. All right, so what I want to do now, so I built my app, right? So built my image. So I want to run it, and it's simply Docker run, and if I can remember what I called it, and basically all it did is it spun up Docker, which spun up the JVM and ran my Java app, right? Simple, right? But if you think about this, I just ran time here with it. It did that all in about a second. So, you know, there's no way you could spin up a virtual machine, have it load the operating system, all that stuff, load Java, run your Java app in like 1 second. So this just ran a simple Java app in 1 second from start to finish. Now, if I wanted to run Docker, I wanted to run dotCMS inside of Docker. I could say Docker run. I won't do do that for now. Let me get the name of the image here. And actually, while I'm thinking about it, I know some people joined in late. I'm going to paste that image in here for you all to be able to follow along and reference this document after the fact. All right. So my Docker image name is this .cms/.cms, et cetera, et cetera, et cetera. So I could run our Docker image like this. Now, some of you I know have messed with Docker. What would be the problem if I just ran this command like it is? This is the ask a question, make sure somebody in the audience is still awake. If I ran this command like this, what would happen? Okay, so if you're talking, if you're talking, you got to unmute your mic, because I know some of you are in the box boat discussion. You should know the answer here, right? All right, this time, Chris, we'll let them off the hook. You can answer.
So it would actually run, but it would run in a foreground as a foreground process. And it would not have any network ports bound.
Right. So essentially, it would run the process, but you wouldn't be able to access it except from inside the container, right? Because Docker is going to isolate the process and the network and the file system of this container. So there's no, it's kind of like, it'd be the equivalent of starting an EC2 instance up in Amazon, right? And not giving yourself access to the security group to it. It's like it's running, but it's not doing any good because you can't access it. So the way we'd access it is we would say -p and basically say 8080. And all this is saying is I want my local system, the host environment's port 8080, to expose port 8080 from inside of the container. Again, if we don't do this, the only way you could ever use dotCMS would be to actually log inside the container itself and then curl localhost. It would not be available, outside of the container. So the other thing, I'm just going to copy this command now because I don't trust myself to type it all.
Hey, Brent.
Yeah.
We did have a question kind of on the concept of layers. Could you real quick do a Docker image history on the .cms image so people can see how the different layers are broken down? Yeah, so this is basically for every command that is in your Docker file that you actually use to build your Docker image, it creates a unique layer. So for our .cms image, and there's some cleanup operations that happen after the fact, so some of these image references, IDs, the actual layer IDs are missing. But for every command that's in your Docker file to actually create the image, it creates a new layer. So this is showing the history of everything that happened to build this .cms image and the size impact of that command. So you can see a lot of these were kind of almost like no op type, no impact on size. Some of them were big. You can tell pretty exactly which one contains the .cms file because it's 459 megs there. So that's where the layer caching really comes into play. And where if you have things that are cached well, you can avoid downloading a lot of things repeatedly.
And by the same token, if you go to download an image that you already have, but it just has a different tag on it, it just downloads the tag, right? It's like it's smart enough to know, okay, I have the hash of the thing, and you have it here locally with a different tag. I'm just going to retag it rather than re-download it.
Yeah. Within the Docker ecosystem, everything is checksummed and uses those checksums consistently. It's, I guess, similar concept to Git in that aspect. But yeah, it doesn't reinvent the wheel. It doesn't have to. It doesn't repeat itself. So it has a lot of file integrity optimizations for that as well.
All right, well, I'm going to kick this command off, and then we'll talk a little bit about it, see if anybody has any questions. So if we look at this command, the one thing I stuck in there that I didn't explain yet is this part here I've highlighted. Basically, just as we expose the port, you also Within the container, by default, all the storage is within the container, okay? And it has the idea of volumes, where you can map or mount volumes into the image. And so this command -v for volumes, and what I've done is basically said, take this local license.dat file, and I want you to mount it inside of the image at this location. And so if all goes well, and my license is not expired and all that jazz, once it comes up, it should come up with a Prime edition rather than as a community edition. So it's going to take just a little bit longer here for it to come up. Does anybody have any questions? I know we're going fast, but anybody have any questions about what we've covered so far? Is anybody out there? This is what Dean feels like.
Also, you didn't see the message, but I solicited for questions on the Docker Slack channel too. So if anyone has any that wants to handle them asynchronously, feel free to chime in there.
Excellent. I should put that where I can see it, I guess. Any so the question about layers, okay, looks like you already answered that. The idea with layers, you would kind of structure them in the order where the least likely this change stuff happens first, so that you can get the most out of caching there. I don't have a definite opinion there. I know Chris, you've looked at it a lot more, but I think ideally you want to be able to cache as much as you can. But when you're rebuilding a whole entire .cms the way we do, there's not a whole lot of benefit to the caching for us.
Yeah, and within the Docker file, certain commands kind of check for cache changes differently than others. So there's some anti-patterns that you can easily fall victim to, where you run stuff that's not cache busting correctly and is breaking your build. So there's the Docker file layer caching is its own beast. But there's definitely optimizations made there.
Any other questions or comments before we go on here? We'll have time at the end as well, but I'll just give you an opportunity here to. Okay, so yeah, Brian, the database we're using here is by default right now, we're using H2. We're going to give an example here in a little bit where we're actually going to use Postgres, but the image we're using right now, just because we're running dotCMS by itself, is H2. And it's all running in one container right now. Again, we'll change that here in a little bit. All right, so I'm accessing localhost port 8080, which basically, as we saw, is mapped to my containers port 8080. Very familiar with that. We'll just look at the login page here real quick. And something happened. My license is either expired or something. But dotCMS.
I saw a community in the logs there.
Yeah, so dotCMS is up and running all in a single container. Now I'm going to stop it. Control C here, because it's running in the foreground. It's interpreted that as, hey, shut down the process, and so it's going to terminate dotCMS and terminate the container. So let me ask you this. When I did this, and Chris is not allowed to answer this one, so I need somebody else, okay? What happened here to my database, my assets, and my Elasticsearch index? Come on, JT. I know you know this one, man. Somebody.
They're gone.
They're gone. John Michael, you here?
No, it's Vianney.
I'm here.
So what happened to my database and my assets and my index in this case? I just ran this command here. I did a Docker run and then I killed it.
I actually don't know. I haven't touched the thing since we had the thing, but
Understood.
I would think it'd be gone.
Okay. Yeah.
Brent,
Go ahead. Yes.
I have a question before. I have a question before answering your question. Are your database and the Elasticsearch volume in the same image? I mean, in the same container, because if they have in another container, that's the problem.
Okay. I'm in the process of answering that on Slack right now, actually. as a follow-up to Brian's question. Yeah, so the Docker infrastructure pattern is basically a single process per container is what we strive for. So for any container, you should only run one process. In the real world, it's not that simple. You do need some accessory processes. But so in the real world, it's more you have one concern per container. So what that translates to for dotCMS is you would never want to run both the dotCMS JVM and Elasticsearch or database or anything else in the same container. So that's where we get into, we call it container orchestration. So we have multiple containers that are kind of orchestrated to work together. So we'll have a dotCMS container and a Postgres container and an Elasticsearch container. And that's what we're going to demo after the single instance. But there's a very, well, actually there's way too many ways to make multiple containers work together.
Right, and so you're very astute there, Nolly. We're going to get there here in just a minute about how to run multiple containers. But for what we're doing right now is we just ran one container with dotCMS, which essentially, functionally, it's a Docker version of downloading the tar file, untarring it, and running it, right? It's kind of like the demo, right? Download and run it. What happens? You run an H2 database, and everything kind of defaulted for you. Same thing here in this image. So John Michael's right. What would happen essentially is all that data is kind of gone. I say kind of because it was all in the container. If we do Docker container ls, that'll show us all the containers that are running. We killed our container, so it's not there. But if you add the -a, it'll also show you containers that have been terminated. And we can see here's our dotCMS container. Now, the reason I point this out is as you're getting used to Docker, you may have made some changes or something inside the image when you're debugging and you forgot them or something like that. Not that I would ever do that. But basically, using the Docker commands, you can actually restart a container. So let's say for some reason I had a piece of data or a batch file or something in this container that I needed. I could actually use the Docker start command, pass it this container ID right here, and it would restart the container, and then I could get inside the container, get the data I needed, back up the database, copy the file, whatever it is. But for all intents and purposes, it's gone, but it is preserved until I clean my system up. And once the next time I clean my system up, all those legacy containers will be gone, and at that point, it's really gone. All right. So yes, as people have astutely got there already with the questions, you can see how running this command, even just mapping in the license file, you start to get a pretty long command line. And then if you want to map a volume for your assets and for your database, and it starts getting unwieldy, right? And then as was already been pointed out, we don't want to run just one container, right? We want to run the database in a separate container from dotCMS. We might want to run Elasticsearch separately, all those things start getting more complicated. And as Chris alluded to, now that's what they call orchestrators. The idea you need something to orchestrate all these containers and how they interact and talk with one another. So the first example that we want to use there, as we talk about that, is DrCompose. DrCompose is a developer-friendly tool to let you basically orchestrate containers in a developer environment. This is not something that probably anybody's really using in production necessarily. It's more of a developer tool. But as we'll see, we'll actually look at this DrCompose file very quickly. And again, not expecting you to master all this, but want to expose you to it so you can come back later and look at it. First line is just saying what version of DrCompose syntax you use. That's handy because if somebody tries to run your file with a version of DrCompose that doesn't support that version, it'll give an error, right? So I actually had this, I was wanting to test something on one of my other systems and I tried to run it this morning and said, this version of DrCompose is not supported. So I had to update my DrCompose version in order to run it. And that just controls what syntax you're allowed to use. At the bottom in the resource reference section, there's actually some links there to documentation of what all these different things are. First things is setting up networks, right? So if you're familiar at all with production type environments, you're going to have the HTTP is going to be our network where things are coming into the load balancer. The load balancer, or I guess not into the load balancer, but that the load balancer is using to proxy to Tomcat. And then we got the database network where just dotCMS talks to the database. That's what that network's for. Elasticsearch, and then Hazelcast, which we're using for caching. Volumes. I don't want to go into detail here, but essentially this is a way for our developer.
Docker volumes are kind of a rabbit hole.
Yeah, they're a rabbit hole, and there's a lot of different variations and things to them. But essentially the thing to keep in mind here is this is just what we talked about, is this is a way that I can persist my Elasticsearch data. I can persist my CMS information that I want to persist, i.e. assets, and then I can persist my database. And we'll see down below where those are used. So now the services section, this is where you start defining, okay, here's all the different services, slash things that are going to run inside of containers. I'm going to start defining those. So the first one we define here is an HTTP service. This is for where we're at right now is just Trafic. That's just a load balancer. It's, we're using it like we use Nginx now, where it's basically a front end load balancer and can proxy to one or more dotCMSs on the back end. Let's see, we're mapping in the configuration file here. We're telling it what network to use. And then also because you're dealing, actually we'll get to the deployment stuff later. DrCompose doesn't use this, but the same file can be used also by a tool we'll talk about here in a little bit that gives you more capabilities. Hazelcast, we're telling it what image to use, etc. Let's just go down here to dotCMS. So basically we're saying, okay, the dotCMS service, here's the image we want it to use. Here's the environment variables we want it to set, including the Java heap. We also tell, okay, this service actually uses these other 4 services. So it should start up these other containers before it starts up dotCMS because dotCMS expects them to be there. And then we have the volumes. Go ahead, Chris.
It depends on, it means it should start these services before it starts .cms, not necessarily these containers. When you deploy a service just basically allocates a request to start a container. Once that request is allocated to a host, the service, Docker thinks the service is up. So it depends on, doesn't actually verify that the service is up in a realistic sense. It only means that someone accepted a request to start a container.
Yep.
So it's, it's kind of a shifty thing.
Yeah, it's like it's a way you declare dependencies, but when you get into the details, it gets a little tricky. I was gonna
Major headache.
Yeah, I was gonna spare some of the details for now. They get into that pain later, but
yeah. Yeah, core thing is don't trust depends on.
Yeah. So it's mainly conceptually to understand, what's going on here, right? So this is how we define it, right? And then we see down here is our Postgres database. Okay, so what I want to do now, the other thing I want to just look at real quick, we're also going to introduce the idea, we're going to have a plugin. Okay, so some of you may be wondering, like, okay, so I've got this immutable Docker image that we're going to distribute to the world. How are they going to get their plugins in there? Well, when the Docker image starts up, you can dig into all the details later with the links I've given you. But essentially, part of that image starting up is it's going to look to see if you have a plugin folder mapped, which if you look back in our DrCompose file underneath of this, you'll see we have this right here. We have a plugins directory mapped into our image at /srv/plugins. And the startup scripts are going to look and say, hey, do you have plugins? If so, let's deploy them. So we've got a basic plugin here, got a couple of our properties files, and then we are overriding, the startup script and some other things, in our plugin. But what I want to do now is, let me get to the right tab. Actually, let me make sure nothing's still running because I don't want to mess myself up there. Okay. And this command I just issued right there, Vianney, I know you'd probably be interested in that. It basically is cleaning out all my old containers and all my old volumes and stuff in a single command, which is really nice. All right, so I'm in dev. So now all I have to do to bring up, so if we look at this compose file, all these different services, actually I haven't even counted them. How many are there, Chris? Like 6, 7? All I have to do is say docker compose up. And what it's gonna do is it's gonna look locally for that Docker compose file. And as you can see, let me scroll back up here, it created all the networks that I specified in there. It also is creating volumes for the data, and then it's gonna start going through and creating the actual instances of those services. Couple of interesting things, kind of the default standard, I guess best practice, if you will, is for Docker processes to map to standard out. So what you're seeing here on my screen is, by default, it's going to output all these different messages from all these different containers. So the container name is on the left and the message is actually on the right, which can be overwhelming, but at the same time, for even just today, as I was looking at some startup problems, it's actually kind of helpful, because when you have Elasticsearch externalized and your cache externalized and your database, this kind of is letting you see the world with all those log files kind of interwoven for you. Depending on what you're trying to do, that can be a really good thing or a really bad thing. But I mean, going forward, like in production environments, obviously we're going to need to have a solution that's going to grab those logs and pipe them to proper locations. So as you can see from all the different messages, especially here at the beginning, right, it's starting up all those services. It's starting up Elasticsearch, Hazelcast. We also have a static Elasticsearch. So the important part to think about when you think about the containers and the clusters, if you have a cluster of all these Elasticsearch containers and they just go away, you have the same problem we had with our standalone dotCMS container, is what happens to my index, right? It's gone. So you have to have some way of persisting that index so on a restart, it's still there. And so our solution to that is we have a static Elasticsearch index, essentially the same as the normal Elasticsearch, except it actually is going to persist its data onto a data volume. So in a production environment, that would be like a NFS file mount that it would save that data to. You couldn't have all those containers writing to the same location because they would corrupt each other. So we only have one of them that's really persisting that data across restarts right now. All right, let's see where things get. All the database created, okay, it's still coming up. Anything? No, okay, there's the problem. The reindex will try to, yep. I don't think it's going to start up this time. We'll see. But essentially with that one command, docker compose up, it's going to spin up all these services and they're all going to be live and talking to one another here. If my .cms doesn't get stuck trying to reindex a record, that sometimes sporadically happens. Any questions or comments while we're waiting on this to come up? All right, I think everybody's at their afternoon naps or something. Everybody's. I knew it was a danger when I scheduled it for the afternoon, but I hate to schedule something in the morning when people often are their most productive. Okay. All right, so unfortunately, this container is not going to, dotCMS is not going to start up cleanly because there's actually a bug filed for this. I know there have been some difficulties reproducing it, but when you restart dotCMS as much as I have, you see it quite often. It gets, for some reason, 1 or 2 records get stuck, and it's going to be forever trying to reindex those. So let me just show you. Oh, that's right, because I ran it. I'm not to there yet. here's the list of containers it's running. So DrCompose spun up all these containers, based on our DrCompose file. You've got dotCMS itself, you've got the database, you've got the load balancer, you have Elasticsearch, you have our static Elasticsearch, have our external caching of Hazelcast, and we have the Man Center, which is a tool that we can use to see inside of the Hazelcast cache. All right, so what we're going to do, unfortunately, that didn't boot, but that's okay for the purpose of our discussion here. If you want to take it down, you just say DrCompose down, and what it's going to do is it's going to shut down the services. It's going to remove the networks. One thing it doesn't do by design is it doesn't take the volumes down. So if I do a Docker volume ls, here's the different volumes. Now, these name volumes is stuff that it's creating internally. These three here are the ones I specifically created myself, and that's where the persisted data lives. This is using what's called a named volume. If we were doing this in a cluster or across multiple machines, we'd have to not do named volumes. We'd have to actually put it on a file share. Okay, and then I have a note in the document here. Not sure why. You know how it is. You go to do a demo and things don't all work. It doesn't work right now, but once we get this problem fixed, you'll be able to just say DrCompose up and do a dash scale and tell how many instances of .cms you want running or any of the other services, and it'll change those. It'll add another instance or something like that. So I see this being really helpful. I know one of the difficulties now with testing or with debugging clusters is, you have the whole port conflict problem, but this gets around that because all those ports are in separate containers, which are all isolated from one another. And so you can actually, if you have enough memory, you can run 2, 3, 4 instances of .cms on the same server in a cluster without any port conflicts. Any questions about DrCompose? All right. We've been going almost 50 minutes. I would like to hear from you. Do you want me to go into Docker Swarm? Docker Swarm is basically an orchestration. It's a freely available orchestration that's included with Docker. It basically uses the same file as DrCompose. It's a little more production friendly and also supports, running multiple nodes on the same or on different machines. So you could actually hear DrCompose. It's running multiple containers, but they're all on the same host machine. With Docker Swarm, which takes the same input file as DrCompose, you could actually have 3 different machines, all as separate nodes, and all getting assigned containers to host. If you saw the webinar, the webinar link, if you watch the second half of that, we actually kind of did a demo of that. I'm willing to do that here, but I don't want to do it unless people really think that's valuable right now. So we can either move right to Q&A or we can cover Docker Swarm. Thoughts? So my tendency right now is to skip it unless somebody thinks it would be good to hear. And you're probably like, we're tired of hearing you talk. Move on, and that's fine. Anybody want to hear about Docker Swarm? No? Talking to dead air.
I'm good, but I've seen it before.
Oh, Alfredo did say go ahead with Docker Swarm. Okay, that's great. So let me clean up my system here. Make sure I don't get stuck with anything laying around. And I included links here. So if you go to the Docker Swarm, it's going to take you in the repo where the different files are, like the stack compose file, those kind of things. Those are all linked there for you for your reference. Let's see. So I'm here. Clear this so I don't get confused. Now for me, I just have this, there is this script file I did check into version control because you can run Swarm on multiple, across multiple machines. And so it actually has, let's just look at that file real quick. Instead of using the name volumes like we were doing before, probably the most interesting thing about this is here we used to say CMS shared or something like that, just gave it a name. Here it's a path. So what that means is this is actually mapping to a location on the host operating system's file system. So for example, when I run this in a networked environment and running multiple nodes, I create a NFS share and then I mount that on all my host machines so that they're all reading and writing data from the same location. So that's the main difference here with the data volumes, is that we're mapping to an actual location. If you look at my script, all it's doing is it's deleting my data directory and kind of rebuilding it from scratch. So we can kind of look at.
Yeah, the host-mounted volumes are much more likely to be what you'll see in production, but the named volumes are much more portable for testing and QA.
Yeah, and the named volumes are much more self-contained, right? And so I could have, if I wanted to set it up, I could have multiples of those, real easily for different versions or whatever. This kind of takes more setup work because I have to set up a directory structure outside of whatever directory structure I'm working in. So you can kind of see here, this is kind of what my data directory looks like right now. All right. Now, somewhere I have that command. I did put it in the document. It's important to note you've got to have the /data, because I'm using that in the mount. You have to have that added to that dialog I showed you earlier in Docker so that it's available. Otherwise, you'll get a weird error like I got earlier. I think I put that up there. Yeah. Invalid mount type. Invalid mount config for type bind. It was because I didn't have my /data set up in so my virtual machine would have access to it. All right, so the main thing to think about Swarm is you have to initialize it. So yes. Yes. I always forget that one. All right, so first time you're going to use a Swarm, you have to initialize it. And in a Swarm, you have manager nodes and you have worker nodes. And of course, when you initialize the Swarm, it's going to set up a manager node first. And it shows you, hey, on all your worker nodes, you have to use this command here to make it tell this manager it wants to be part of the Swarm and all that business. Now, for our sake, we're only going to have a single machine in our Swarm, just for simplicity's sake. But we initialize the Swarm. Wait a minute here. So what I can do, if I do Docker node ls, it's going to show me all the nodes of my Swarm. Of course, we only have one. I need to know that Docker, that Docker node ID. So I'm going to copy that. And you might be saying, why are we doing that? And that's because if we come over here, if you remember our Elasticsearch static guy, he's kind of special because he has to persist data. So we have a deployment constraint on him, and deploy is only used by Swarm. The deploy tag, I should have pointed it out, but when you start up with DrCompose, it basically says, look, I don't understand this deploy tag thing. I'm ignoring everything underneath of it. But it's there because we use it with Swarm. It says, look, you can tell it where to place it. And here we're specifically saying a node has to be labeled with a static flag in order to get this container. Because if it's not labeled, we can't be sure that it actually has the ability to store that data, after the container restarts. So I'm going to add this label so that this node I'm on will be able to accept the Elasticsearch container. All right. So what we'll do now, I'm going to run this command, and then we can talk through it as it's running because it's going to go well. So all this is really doing is it's exporting an environment variable called stack name and giving it a value. This is kind of a technical reason because with traffic, the way it works is we have to pass a name to the network that we're passing in the traffic label. The problem is, and actually you can see it here even in our output, right, is by default, when it deploys a stack, it's going to give it the name. It's going to give it a name, and it's going to prefix that to everything. What turns out, we found out from School of Hard Knocks, that traffic expects the dynamic, fully qualified name. And so the way we're getting around that now is we're defining a variable, and then that variable is actually the name of our stack that we're deploying. And then here in our stack compose file, we're using that same variable so that traffic gets the right value passed into it. So yeah, let's see where we're at. So if we say Docker service logs, this is going to keep me following the log for dotCMS here. But essentially, this is doing everything that DrCompose did, but it's doing it in a way that lets us control the placement. It also does it in a way that if I had multiple network machines set up, I could deploy containers across multiple servers. Any questions or comments about anything we've talked up to this point? So while this is going, then I guess I'll just talk a little bit more. I mean, I think as we get things, ironed out here, I see a lot of value. I think as it relates to distributing dotCMS and Docker, I think it's going to make it easier to deploy a standardized dotCMS with all of its dependencies. That's going to be, there's going to be a learning curve to it, but once we're past that learning curve, I think it's going to make it easier for us to support dotCMS in different environments because, again, we know that they're running with the specific version of Java and all the other dependencies for SAS, LESS, all that stuff is all contained within the image itself. And so we know that customer A and customer B are running the exact same images. So it kind of takes a lot of the variables out of the equation. Of course, there's still problems that can happen, and I'm sure they will. I also see value for testing in that it's going to be much easier to set up a cluster than it has been in the past. And also for developers, if you want to be able to debug a cluster, it's going to be easier to do that. And so I think it lowers the barrier there. I think it's also going to make it easier for us to do deployments in an automated fashion, because it's just basically take these containers and deploy them into these standard environments. I do think as we get more comfortable with the technology, I think this is where, as you all work with it, you'll start coming up with your own ideas and also think about how to flush some of these things out. For example, the way we set up, I mean, I'm just saying this might work. I haven't actually done it, but it seems like it might be a good use of it, is, the way we set up our local developers running test environments where it pulls down the Tomcat repo, right? It copies down that whole repo and then copies stuff inside of that repo. It basically builds the war and then copies that war inside of the Tomcat repo. And it's like, that seems to me like we could have a Tomcat Docker image that instead of copying stuff in there, you just mount a volume and point to the war file and mount that war file into the Docker image. So I see a lot of, I think as we get comfortable with the idea, we could have a lot of different uses for it. All right, I think I saw.
And as we actually try it in production and see what breaks.
Yeah, so one of the things we're going to be working on here is we're going to be working on getting demo to run in Docker, right? Because we kind of want a production environment where we can learn from, find our problems, and learn and make things better before we have too high of a risk. But part of the idea seems like an ideal candidate for demo, right? Because you're blowing away and you want all the demo data to be gone, right? So it's a pretty good fit for that, I think. All right, let's see where we're at. Okay, it's started up, I think. Now in here, because we're using a load balancer, it's actually listening on port 80 instead of 8080. Okay, so it's up. Okay, it picked up my license.
With Swarm, there's some kind of weird magic going on behind the scenes to handle that as well.
So yeah, we'll see I picked up a license file here. If I look at the index, I guess the thing of interest here is I look at these index, right? And I have 3 ES nodes. This first node that has the different name, the name that's different from all the others, that's the actual dotCMS instance. These other nodes, one of them's the Elasticsearch static node and the other is the normal Elasticsearch node. And if you look, that's where all the documents are stored, is on those nodes. And because we're relying, in this configuration, we're relying on external Elasticsearch to handle all Elasticsearch stuff. So our dotCMS actually has a 0 document count. Anything you want to add to that, Chris?
Moving towards the it's moving towards the ideal of the completely stateless application server. In the stack, the dotCMS server has no data on it and is completely disposable.
Yep.
Anything that actually contains application state is elsewhere and is carefully constrained and managed.
Right, and if you're a client like S&P that really uses Elasticsearch heavily for relationships, you can scale the Elasticsearch nodes. Just because you need 5 Elasticsearch nodes doesn't necessarily mean you need 5 dotCMS nodes, right? And then also externalizing the cache would help us, keep the memory footprint of the dotCMS process smaller, for example. And be able to scale the cache independently, again, of dotCMS instances themselves.
Hey, Brent, I think the index here is underperforming. Can you add a node? Can you scale it up? Or do you have enough memory? I guess is the other part of that question.
I should have. Can you tell me what that command is offhand? I'm not sure I know it off the top of my head.
This is you're on your Swarm, right? Just to make sure.
Yeah, I'm on my Swarm. Yeah.
It's a Docker service scale, and then the service name equals the count.
Okay, Docker service scale what?
Yep, and then demo underscore Elasticsearch. That's your service name. Equals 2. All together. Yep.
Right, so this is where I'm basically telling it to add a second Elasticsearch node. And where would so I'll see Docker service ls. So here I can see my Elasticsearch has 2 of 2 replicas, so I know it's running there. Yeah. I guess what if I reindex it, I should see it in the index?
You shouldn't have to do anything, just refresh.
Yeah, there you go. So let's see. Well, that's interesting.
It takes a minute to sync the index.
Okay.
Yeah, they're all there. They're out of order.
Yeah. So, but as you can see it, right? So now we had 3 of these before. We now have a 4th one because we just added it. And so that's the idea: is we can add Hazelcast nodes, we can add Elasticsearch nodes.
In a matter of seconds. In the real world, with a real world size index, it takes a little longer to converge the index replicas. Yeah. And one note here for those that have worked with Elasticsearch, in Elasticsearch, replicas means additional copies beyond the primary shard. In Docker, replicas is just a flat how many of these are there. So it's not the same thing. Docker replicas are not the same as Elasticsearch replicas. They work differently and will throw you off until you get really used to it.
So I also, while you're talking there, Chris, I added a dotCMS node, so that should be interesting. All right, any questions? I feel like I'm boring everybody absolutely positively to death. All right.
Hey, Brent, are you using master or another branch?
We're using master, and if you look at, let's see, this was master as of 3 days ago. The snapshot we're using right now, you can look at the tags in hub.docker.com. It was master as of 3 days ago, yes.
Cool.
So we've been doing that because at the very beginning we had some Elasticsearch. We were really needing the Elasticsearch upgrade, which you guys did, and then we've had a few bugs here and there that you guys have fixed. So we are trying to stay pretty current on the code you guys are developing.
Yeah, we are not looking at backporting any of this to the 4 series at this time. There's a lot of stuff broken in 4.3 as it relates to this whole stack. So it's really focused on 5.0 moving forward in the future.
Also, Brent, question here, Daniel. How far are we from actually using this for QA?
Well, I would like to see us use it as soon as
this meeting wraps up in a few minutes here.
Yeah, after we're done here.
Go, Brian.
This is the whole purpose for Brian and everybody else. You know, everybody else is responsible for quality too. So, no, the idea would be as soon as you guys are comfortable with it and can work it into your process, I think that would be good. I guess you guys will have to talk through that about how that relates to the 5.0 deliverable and all that. You know, I'm not saying, hey, slow down 5.0 because of this. So, and the time frame for this stuff here is we have a meeting tomorrow to kind of talk with Tim and Arno and gang to kind of figure out from a business standpoint what done here and how they're going to kind of position this and sell it and support it. Once we start having those kind of conversations, we're going to figure out, okay, what do we need to do to make sure support is, you know, what do we need to build, first of all, exactly? What do we need to do to make sure support's ready to actually support it once it goes live? And we'll start working through all that. So what we basically said is, look, it's going to be released in the 5.x series. Docker is not going to be ready out of the gate when 5.0 releases, which my understanding is that's next month. But the idea would be we'd want to get it officially released as soon as we can be ready for it on the 5.x series. So maybe a 5.1 or something like that might be when be ready to officially support it. But yeah, I would love to see people start running in it. My experience so far, I've spent a lot of time. So I literally, and I kid you not, and actually have a little bit of evidence of this. If you go to the hub.docker.com, it'll show you, let's see, how often something's been pulled. Where is that information at? You can see, wow, it's been up to, this repo has been pulled 2.9 thousand times. So I've done, between Chris and I,
we've done some testing.
We've definitely done some testing, and I've my first step, right, is I don't want to file a bug for you guys like, oh, you know, we got this bug and it turns out to be Docker specific. So I go over to my Linux box, I fire up the nightly build or whatever to recreate before I file the issue. And I mean, we have some issues, as you've seen, with discovery and that kind of thing that I know are, Docker related with our scripts and stuff. But as far as dotCMS functionality, every bug that I've found so far, if it's a bug in Docker, it's been a bug in the, standard deploy of the tar file as well. So I've not had a bunch, it's not like I've had a bunch of bugs like, oh, it turns out it's only broken in Docker. It's actually been, oh, it's broken in Docker. Let me check to make sure, but oh yeah, it's broken in the nightly build too. So from my standpoint, I can see a lot of value in being able to quickly build and deploy. And it's probably worth talking about that just real quick. I'm not sure why I didn't put that in the presentation earlier. The way we want to build images right now is this project here. I'm putting it in the chat. Basically, you can point it to a tar file. So, for example, what I will do is I'll point to a nightly build URL, and that'll create a Docker image for it. And there's a specific example here of exactly what to pass to make it build a Docker image from a tarball URL, which in my case is the nightly builds.
Or commit ID if you want to test a specific commit.
Okay, that's it.
Difference is any of the tarball release uses a pre-built binary artifact, whereas the commit and tag has to actually build dotCMS, so it takes quite a bit longer to actually do the ones that build versus the ones that just use a pre-built artifact.
So yeah, I mean, to answer your question,
it's still like 5 to 10 minutes if you have sufficient bandwidth.
Yeah, just depends how long it takes you to download all that stuff. Yeah, so I'd say the sooner, I'm saying this from my perspective, Daniel. I mean, I think you guys, along with Will, have to figure out what you want to do. But from my standpoint, I would love to see you guys doing a fair amount of your testing inside of Docker itself. But I realize that maybe with your time schedule or whatever, you guys may not want to do that until 5.0 is released. I don't know. But I'd love to see it sooner than later. I would love it if at least half the people on this call, in the next week or so, run it, right? I mean, I've given you everything here in this Google Doc you need to actually run the thing. We need people to start getting familiar with it. I do think, it is one of the ways that we're going to start deploying the software to the public. So definitely people in support and the developers who support the support personnel need to be somewhat familiar with it. And I do think as we get more comfortable with it, there's going to be ways we can really leverage it internally for some efficiencies as well. But that takes all of us kind of getting into it and getting a little more familiar with it.
Also, Brent, my second question would be: is everything we would need all in capture in that and in the Google Doc you sent, or do we need something else from somewhere else?
Yeah, I mean, everything you need is in here.
Okay.
Yeah, I think that was my intention anyway. The one thing
probably condense it down to a how-to.
Yeah, we could condense it down to a how-to. At the bare minimum, this dotCMS example here, that command right there, if you have a licensed DAT file, you could run that right now and it'll download that image and it'll run that thing.
Okay.
DrCompose, you have to have this repo checked out that I have hyperlinks to. You have to have that checked out and you have to run it from inside of that directory.
Hey, Brent, quick question. For now, we only have configuration for Postgres, right?
That's correct. Right now, that's true.
If you, the other.
Sorry.
So within the stack, you can configure it to connect to a database outside of the stack, just using your standard context.xml. But we're not looking at building Docker images for anything other than Postgres. For our standards Docker stack, Postgres is going to be it.
Right.
Yeah.
But if something else, you have to connect to it outside of Docker.
Okay. I was thinking in testing purpose, I always need search engine databases and something like that. Then use asking to see if we have some pre-configuration for the other database. But
yeah,
okay.
It's doable for testing. Yeah, it would just be an external resource from the Docker stack.
Right.
Jose Orsini here. Hi, everyone. Sorry for joining late. I was out sick today. So question, for having an external database which is outside this dotCMS, this Docker stack, would it be only necessary to expose the port that we will use for database connection on the DrCompose file?
Right, so all you have to do there, if you want to use a database outside, like let's say you have Microsoft SQL installed locally or whatever, on my screen now I kind of have the context XML from the plugin that's in the database. You can see that we pass the server, the port, and the database name, and then we also do the same thing for username and password. So all you would really need to do is set those environment variables in your compose file. So if you look at, here in this section here, we have environment variables. Right now, those specific variables are not set because we're using the defaults. But if you wanted to, you would just need to set those like db_server, set that to the value like localhost, your port, your name, database name, etc. And then that would.
Well, so localhost won't work though.
That's true. I'm sorry. Good point.
So each container's kind of network environment is virtualized. So each container has its own unique network stack. And then each of the networks that are attached to the container have their own completely isolated networks. So when you're going from, say, the dotCMS container to the Postgres container, the dotCMS container has like 5 or 10 different IP addresses on it, and each one being on a different network. So it connects to the Postgres container over the Postgres network directly. But localhost is not going to be a real localhost. It's going to be a localhost within the container. So what you would need to, so if you try to connect to a network that is not one of your Docker networks, it's going to go out over basically the default gateway from the Docker environment. So if you wanted to connect to a database that's running on your laptop, you would have to use your laptop's real IP address. In that IP address, and it should be able to connect to it, and it'll just go out the default gateway from Docker to the database.
And I'm glad I made that mistake, because I make that mistake a lot. I still forget that. So yeah, if you're running 6 containers on your laptop, you have really 7 relevant localhost IPs, right? Within each container, the localhost resolves to that container itself. And so it's like a mindset change, right? So dotCMS is running inside of a container. So if you would have done what I said and said localhost there, it's going to try to connect to a database running inside the same container, which it's not, and so it will fail. And to Chris's point, then you've got to be able to point it to an IP address where it can actually find the database, which is not going to be localhost.
Yeah. But you can do that. I haven't used it for a database, but I've used it for other types of connectivity to be able to connect straight to my laptop.
I see.
Actually, use it when I need to copy a file out. I SSH to my MacBook from the container or SCP.
I think it's also worth mentioning that in case that we don't want to use the Postgres database, or at least the Postgres container, we should remove that as a dependency by the time we're building the Docker service here, because we will definitely won't use this container or images created in Docker in case we're trying to ping an external database. So I think that's worth documenting as well, in case that someone at QA, for example, Brian, would like to get it tested against MySQL or Oracle. It shouldn't be necessary to bring up the Postgres container here. Sure. Whenever he decides to do a test here.
Sure.
Yeah, the stat compose files are really easy to change, and Brent and I have like 10 different, probably more than 10, 50 different variants of them that we use for different test scenarios. So you definitely iterate that and change that a lot depending on what you're testing, what you're trying.
And I think,
it's really lightweight.
Part of that's getting used to it, right? And the way I kind of look at it, pretty much everything you can do in a compose file, you could do from the command line, but it'd be a really, really, really ugly command line. And so it's kind of like, how do I want to call it this time? And I think, we all need to get familiar enough with it that we're comfortable going into these compose files and copy, paste, or cut, or modifying these files to do what it is we need to do. I think we all kind of, we need to get comfortable to that. It's going to take some time, I know, but once you get into it, I think it'll come to you faster than you realize.
Yeah. The other thing the compose file lets you do is if you keep that in version control, you can roll back easily and figure out what changed and do some nice change tracking on it.
All right, great questions. Any other questions or comments?
I
Yes,
have a
Brent,
question.
I have. Sorry, go
No,
ahead.
please go ahead. No, go ahead, Noli.
Thank you, Danny. I have a question regarding your roadmap. Do you have any idea of what will come next regarding the containerization roadmap?
Relating to what roadmap? I'm sorry.
Regarding the roadmap in your team.
I see. No, I think we've got some work here to do with some of the discovery stuff. We're still having a few problems here and there with. We also are considering going to HA proxy instead of Trafic. We want to quickly get to the point we can just to deploy in an automated fashion to the demo.cms.com. And once we have that in place, Will's wanting to work towards being able to spin up new cloud POCs, for example, in an automated way. And that's kind of at a high level, that's our map. One is kind of get demo, so it could be automatically redeployed twice a day in an automated fashion. And then he wants it so that, a client orders a POC, that we're able to automatically spin up that environment, in a very quick way for them so they can have access to it right away.
Yeah. And the other thing, along with demo, will be dotCMS.com so that we can get real world usage on there. See how these containers and the stack actually performs in a longer term with real traffic. It'll be really, really important to kind of prove that out before we deliver anything to clients.
And the other important part there, which it's not as technical necessarily, but it is part of the roadmap, is we need to understand how the business wants to sell and support this thing. And then we'll have to make sure we do whatever we need to make that happen. That could affect what is or is not in the image. It could affect, what kind of training we need to provide to support personnel, et cetera. And the other thing is right now our current thoughts are to kind of distribute this with Swarm as kind of the reference implementation of a orchestrator. But, we need to get some experience internally with Kubernetes and maybe one or two other orchestrators as well, so that we kind of understand them. Because once we do this, at least right now, our plan is we release the containers, we release the reference implementation, which is basically a Swarm compose file, Docker compose file for Swarm. And then clients are going to take that and deploy it into whatever infrastructure they have. So if they're using Mesos or Kubernetes or whatever they're using, they're going to take our containers and deploy them in those environments. And when they contact support, support's not supporting, quote unquote, the reference implementation. They're supporting our containers deployed into the customer's infrastructure, whatever that is.
Yeah. And some orchestrators, to put it bluntly, suck way more than others.
Well, I think
Swarm is one of those actually, but it's simple, and it's visually, the way Swarm works is easy to wrap your head around. So it's a good reference implementation, even though in production it has some issues.
Yeah, I think there's a lot of different ways people can deploy. I think Amazon has like 3 different ways right now, Chris, that you can deploy containers.
At least
ECS, EKS, Fargate.
Fargate.
So they have Amazon themselves have like 3 or 4 different ways you can deploy containers, which part of the challenge for us as a company is being familiar with enough of those ways that we kind of have some background. But that's also the strength of containers, is like, hey, everything you need is in this container, and I'm giving you a reference implementation that tells you how this container needs to talk with other containers. And as long as you set that up correctly, we don't care whether you're running, what you're running as your orchestrator. But it's very different from what we do now, for sure. Great. Vianney, do you have something you wanted to say?
Yeah. My question is regarding the challenges that you guys faced in order to make dotCMS more Docker friendly for production environments? And is there any change in the dotCMS core? I mean, do you have any list of the changes that you made?
There's a lot of little ones.
I lost track of the issues.
Yeah. I mean, ultimately, I don't know that we found any issues that are Docker specific. I think all the issues we found are just with having kind of a robust, scalable application. The biggest headaches have definitely been around service discovery and how the different dotCMS components can find and talk to each other. Those have been the most challenging by far, and are still a little challenging, although leaps and bounds better than it has been. But yeah, definitely significant changes. Team Rex did a ton of work with the new Elasticsearch and AutoWire stuff. Some major optimizations for us. I think there's some more to do there. But yeah, and even outside of Docker, the changes that were made to dotCMS for Docker are going to really, really help the dotCMS product as a whole. Yep.
And I think, I definitely think, Elasticsearch was the big area. And I know kudos to Nolly and others in R&D who made those changes to make that possible. Chris has done a lot of work, as he said, in the discovery. So for example, with everything self-contained within dotCMS, it just starts up and it starts whatever it needs, right? But you think about if dotCMS is starting up and it doesn't know, am I talking to one Elasticsearch node or 10? I don't know. I don't know how many to wait for. I don't know how to discover, so you have this whole issue of how does it find all the nodes it's supposed to talk to when it starts up? Because once it starts up, it's going to make assumptions based on how many nodes it's talking to. I would say the other.
And there is no such thing as a static IP address in Docker.
That's right. You can't.
All of these resources are allocated runtime. You don't even know what subnet or what network it's going to be on.
Yep. So you can't. It's not like you could have a config plugin that hardwires IP addresses because you don't know what they're going to be. So yeah. The one thing I would say forward. So what we've done is we've kind of had some logical breaks, right? So we've got dotCMS, we have the load balancer, we have the database. We've been able to split out Elasticsearch and the caching, and those are all good logical breaks. Well, I guess what I would say is we have all these technical people on the phone who are left here. I would encourage us to be thinking microservices going forward, that idea of how can we break functionality down into smaller, independent pieces. What we've done,
clean, elastic interfaces between them.
Yes, and so that's something that I think we all need to start thinking about if you're keeping up with trends at all. I mean, whether it's serverless, microservices are big, serverless is getting big. I think we have to think about what does dotCMS look like, say, 5 years from now or 10 years from now when it's deployed, and we're not going to get there overnight, but I do think we need to start thinking differently. Like we're used to thinking dotCMS, the monolithic program, and we need to start thinking about how can we really break this up in a way that makes it easier to scale independently, support, and potentially maybe at some point actually release components independently of each other. That really is what people are doing. I see a lot of value in it, and at the very least, I just encourage us, we need to be thinking about it, talking about it. I know we're not going to change, it's not like 5.1 or even 6.0 is going to be all microserviced or anything, but as new functionality comes along, I think we really need to start asking, hey, is this a good opportunity for us to define, a microservice or something like that?
Yeah, and in general, as you're rating interfaces, just think of it from the perspective of never assume that what is behind an API interface is what you think it is. It might be something completely different, but instead focus on the API contract that you've established with that API. So API provides this resource, in this format. Don't assume you know anything about what's happening behind that. Don't assume that it's being stored a certain way or anything like that. Just say this is the contract. This is what we're going with. And then the flip side of that is make sure that that contract is solid. Make sure that when you first start that API, you're looking at this is what the API is going to provide. This is the contract. This is what we consume. This is what it provides. That kind of perspective, and make that solid and focus the effort there versus trying to reverse engineer some storage resource that's way downstream. And that goes a long way.
Any other questions or comments? This is good. All right. Well, we've reached the end of our allocated time. I'm more than willing to stay on and talk, but at the same time, I know some people are probably ready to go home and or get back to their other work. So, thank you for everybody for joining us. If you have follow-up questions, please post them in the Docker channel or message Chris or I directly. And I'm glad to have those discussions.
Yeah, and if you do still need access to Docker Hub, just looking at the user list, there's way more people on this call than are users in Docker Hub. Create a user in Docker Hub and then ping either Brent or me, and we'll add you to the group to be able to access stuff. Everything in there is private.
All right. Well, thank you, everybody. Appreciate it. Hopefully wasn't too boring there for you.
Thank you very much, you guys, Chris and Brent. This is great stuff.
Thank you, guys.
Great job, guys.
Bye.
All right. Thanks, guys.
Thanks. Bye.
Thank you. Bye.
Thanks all. Bye-bye.